Let's evaluate some simple logs. So write these down on your paper. Could we evaluate the following? If I give you log of 100, how is that different from log of 10,000 and from log of 1? So these are all common logs. You could put these in your calculator, and that's fine if you want to put them in your calculator and verify what you're doing. But let's also figure out how these work with our log definition that we wrote right there. Okay? So if this is common log, it's a base 10. Let's say we want to find out what it is. It's x. So we're going to circle the wagons around. 10 to the x power equals 100. So 10 to the what power equals 100? Oh, 10 squared. So x must be 2. For this one, base 10 equals, I don't know, let's call it x. Circle the wagons. 10 to the x power equals 10,000. This is going to be 10 to the 4th power because there's 4 zeros here. Now, what do you notice? Hopefully you notice a pattern. X is 2, there's 2 zeros. X is 4, there's 4 zeros. So the next thing we can do is base 10 equals x here. So that is 10 to the x power equals 1. How do we get a 1? Do you remember? Anything to the 0 power equals 1. That's an exponent rule. So anything to the 0 power equals 1. So 10 to the 0 power equals 1. Next, practice solving some more. If you had some problems to solve with logs, here's your first example. 10 to the x equals 3. So I don't know what that is. Let's use log. So we're going to this time uncircle the wagon. So we'll have log base something equals something. So the base goes here. That's also what we call the base of the exponent. So that's 10 to the x is 3. So what does x equal? Now we're going to use our change of base formula. And x is equal to log of 3 divided by log of 10. And you can go ahead and put that in your calculator. Log 3 divided by log 10. And you should get 0.4771. If you're not sure how to get that number, maybe stop the movie right now and see if there's someone else in class that can help you put this log part in your calculator. Okay, let's try another example. 2 times 10 to the x power equals 8. So if I want to get x by itself, I'm going to first divide by 2, and 10 to the x is 4. Then I'm going to uncircle the wagons and go log base blank of blank equals blank. So our base is 10. That's what we start with. 10 to the x power equals 4. Use your change of base formula, log of 4 divided by log of 10, and you end up with 0.602. Now, just remember, if you are given just a plain old log, like log of 5 or something like that, this is already in base 10. You don't have to do anything to it to put it in your calculator. So you would just put in your calculator by typing the log button and the 5 button. Okay, let's move on to a word problem. Olympia, Washington. I think we had a problem like this last time we took notes. Olympia, Washington follows the following population model. P of n equals 1 plus 0.03 to the n power times 245,000. So that's the formula that's going to determine our population of Olympia. This is our rate, and this is our initial value P naught. And N is our number of years, and this represents our population after said number of years. So we could call that ending population. And this is beginning population. So the question is, how many years will it take to get to a population of 400,000 in Olympia? So let's figure out what we know. Pn, that's our final amount, should be 400,000. And N is what we are trying to find out. Everything else in this equation is going to stay the same. So 400,000 is our Pn. Then that equals 1.03 when I add those together to the nth power times 245,000. We are going to divide both sides by 245,000. Go ahead and check your calculator. Yeah, check your calculator. You should get 1.63 for this fraction. So 1.63 is equal to 1.03 to the n power. Alright, so what are we going to do with that n power? We need to solve using logs. So we'll go log base 1.03 of 1.63 equals n. 1.03 to the n, base to the n, is 1.63. Go ahead and check your calculation on that one, and you should find out that n is 16.53. So how many years, if we continue this same rate, will it take Olympia, Washington to get 400,000 people? It's going to take about 16.5 years. Okay?